Hey there, folks. Yes, it's a little bit of an early stream, just during the daylight for a change. I know it's a little unusual, but figured I have to try and be nice to everybody around the world at some point. Plus, I can't do everything at night. Sometimes on a Sunday, I do have spare time. Well, that's not really true. I never really have any spare time. It's always a problem. But I'm trying. Let's see what we can do. Anyway, so I have the new LED ring light aluminium boards. Then we've got 32 LEDs, we've got some current balancing, and we've got a DC jack on here. And I don't know, I'm sure I've missed a few things here. I know I've got one fault. I forgot to put a little tiny trace on one of the transistors here to actually turn it into a current balancing system. But fortunately I can resolve that with just a quick little short circuit, a blob of solder as it were. So what we're going to do is actually do what I'm really not a fan of, and that is to freehand solder paste and then stick the LEDs on there. I'm not a fan of freehanding because the amount of solder you put down is invariably dodgy. In fact, I wonder if I can just... yeah, we'll do it this way. I haven't used this tube. I don't know how long it... This is pretty old, this tube of solder paste, so it's probably due for being thrown out since it's not... hasn't been kept in a fridge or anything, so... What is this? Yeah, this... this is almost 2 years... sorry, it's about 18 months out of date. 18 months out of date, so we'll see how the solder goes, being that old. It should be okay, yeah. Should and will be, can be different things though. Alright. And I have this heat plate, which will make it a bit easier. I got this is the one I was waiting on the last time. I'm quite happy with it. It does do a nice job. And I find usually around about 180 on this is more than ample to reflow that. 180, 200, we might set it at 200. Right. The only downside of having streams around this time, of course, is almost nobody turns up because everybody's asleep. It's too early for the UK, it's too late for the United States, and Australians couldn't be bothered. Normally I would stencil this sort of thing, but well, no stencil available today, I'm afraid. Like I said, I'm not a fan of freehanding. It invariably you end up with too much or too little. Yeah, it's never good. Certainly with solder paste, yeah, a lot of people probably put too much on in general. I know I'm already putting too much on half of those. There's already the hot air there's already the hot air solder layer on there. That's way too much. When you get these boards made, you get the option for what they call the HASL, HASL, and that's just the hot air surfacing layer. And it's basically just like someone went along with a bit of solder and coat the pads. Yeah, I'm getting way too much solder on it. Everything's falling apart messy now. A little more. I'll probably just do the LEDs like this, and I will do the other items, the current balancing transistors, separately. And that's it. Yep, that's it. Hey there, Jim. Alright, now to stick the LEDs on. These are the 5000 Kelvin ones. Let's hope I get the orientations right. Now there's 4 separate channels on this, so we've got 4 sets of 8. So I'm just going to spool off a bunch here. Jose. Damn it, what was the... Okay, there's our marking corner. Now I've got to work out which... okay, so we want the mark corner on the large side like this. Naturally, these are all going to be backwards to what I need. Okay, that one wasn't. They're making a liar out of me. Geez, David, doesn't sound good for your PC there. Hand pick and place is not really the most ideal thing in the world, but sometimes you got to do it. It's one of those tasks that can be very boring, tedious. You really need to have a good supply of music on your in your room. Otherwise, it doesn't take long, and you're just like, I want to get out of here. Hey horse, hey Alexi. Alexa, did you say you're on Windows or Linux? And did you get the software for that multimeter? Ach nee man, I just want to double check something. That's not double checking, Paul, that's confusing. No, I'm talking about the multimeter software. The one that you need for the on-screen display and the data capture. Ach nee man. If you're wondering why, if you can see the traces for the LEDs, you're probably thinking they're a bit on the thin side. But the reality is that because this is a chain of LEDs, that is to say they are like a sequence of 8 in series, and there's only 150 milliamp transferring between them along that chain, you don't really need to have thick traces. So long as the trace can handle 150 milliamp, then you're good. Ugh. Ah, that's the wrong way up. Hopefully that doesn't become a problem. Yeah, it's on the GitHub. If you look up Duratool, it should be on there. It does have automatic COM port detection, so hopefully it works okay for you. If there's any drama, are you going to be, sorry, you're on Linux. Crap. I just realized I haven't thought about the Linux. I wasn't expecting people to use Linux. Okay. I was expecting mostly Windows people. So I may have to, when I'm done with this, go and sort that out for you. Ah, was in the right orientation. Let's see, only 3 more. This makes you realize that sometimes you do actually want a microscope with less magnification. This is as far out as I can go with my 0.7 Barlow. If I want to go out further, I'd have to get a 0.5 Barlow, but then I also need to get a giraffe neck. Okay, I just want to touch them slightly. Alright. Stephen W., in this particular case, I don't imagine that big pores are going to help much. I did think about it when I was doing it, but I just sort of thought, no, I'll just stick with fine traces for now. Because the aluminium's pretty much right there. And 99% of the heat's going to be coming right from the junction on the LED, so I could be wrong, could be a mistake, but wouldn't be the first time. Okay, so power this little itty bitty thing up. Okay, so it's set to 220. We're kind of, yep. Let's how about we zoom in on that. You can watch it reflow. Hey, Tradie Trev. Yep, looks like interestingly, power supply meter has gone bonk. There you go, Brown. Yeah, so we're up to 66 now. 70. There's no ramping control or anything like that on these heat plates. You're simply relying on their inherent slowness to come up to speed to do things in an okay pace. Because you do need time for the board to come up to temperature and the parts to come up to temperature. If you try to flash heat it, like say if you have the hot plate already at 220 or something like that, it just doesn't work out well. So having a slow heat up is a good thing. There's Johnny Chang, there is flux built into the paste. And now, well, it won't be 1 LED, it will be 8. So we're at 160 now. I'm going to zoom in a little more, because I need to be able to see them. I can start to smell it, I can see them starting to move. We're going to give it around about 30 seconds after the reflow. It looks like there was a couple where they could have done a bit more. Just turning it off now. The latent heat will be fine. There's one over here that didn't quite pull around, but that's okay. Gavin, they're 5,000 ones. I'm just waiting for the smoke to clear off the board. And we'll see what we end up with. So I may as well, while I'm waiting for that to cool down, I may as well find my transistors that I need and my resistors. And maybe even the DC jack. Let's see, transistor. If I botch up this, it's not going to be a big problem. I can deal with the lack of current balancing. Now let's see what. So I only got 603 resistors. So I need to get a 603, sort of 1 ohm should be enough. Half an ohm probably would have been better, but I probably don't have one of those on hand. Let's see if I can find a 1 ohm. 1 ohm 603 is actually quite an unusual value for me to have, but we'll see. Otherwise I can go 402, but again I don't think I've got 1 ohm on that. I don't seem to get 1 ohmers until I get into 1206 and similar. I mean, yeah, you can get them. That's not a problem. I'm just talking about what I've got on stock. Let's see. 603, 0 to 10k. A micromage. A PR. Alright, let's go back to full. It's still actually pretty warm. So I'll just put that over there. It's 29.0. I could just use zeros. Because even though there's 0, they do have some resistance in them. 68, 68, 33, 2... Oh, well, what do you know? 1 ohm. I'm shocked. I'm genuinely shocked. I did not think I would have 1 ohms. Ooh. Yeah, that's hot. Put 2 ones in parallel. I'm not going to do that. We'll see how we go with the 1. Okay, so now we're going to do hand soldering. This will take a little bit longer, unfortunately, because of the fact that we are dealing with an aluminium board. Overall, the reflow went pretty good. I've seen worse coming out of my factory. Hopefully these transistors still work. They've been sitting there quietly for probably the better part of 12 years now. Hey Tony, love you. Yes. Pain of trying to hold SOT 23s. Yeah, I know. It's got a bit of a dodgy end on that one. We'll just drag that flux over there. Yeah, at least there's those sorted out. We'll do the bottom legs before we move on to the resistors. Definitely helps having a microscope. Like I said, I could do this without a microscope a decade ago, but definitely not anymore. Hey Charles Whitting. What? These are 1206s, you... No. This is what I was talking about. See, they're 1206s. Actually, or are they 805s? Let's see if one of them might fit. No, don't think those pads are... No. The only way I can get that to fit is if I put solder down and then reflow them. You know what, maybe I'll just do that. They're not going to dissipate a lot of heat at all. I mean, when you think about it, 1 ohm at 150 milliamp, yeah, it's not a lot of heat. So we'll be naughty and we'll just reflow these on top. I knew it was odd that I thought I had 603 1 ohms. I was like, I shouldn't have those. Oh, I better get the writing orientated correctly. More air required, I think. These things do not behave like normal circuit boards. Maybe this is not going to work out. Shit. Yeah, I'd call it a little bit more than just a little bit of hackery. More like a cluster of it. And I've got to remember to do the bridging between the collector and the base on this one. Basically, it just means between that pad there and that pad there have to be bridged. Oh, you are just being a right royal pitter. Hey, what am I talking about? Oh, actually, I mean these two pads here, because that's the emitter. These are the emitters, and you want the base and the collector bridged. Actually, I'll just be back in a second. But no, I hate those resistor books with a passion. Alright, now I'm not going to be able to do a blob from there to there. I'll just run a little while. I hate those books with a passion because they can, a lot of them have problems with quality. I'm not saying yours do, I'm just saying the ones I've gotten in the past, they've, I wouldn't say literally burned me, but they've certainly caused me grief. On the other hand, if you spend $500-600 on a resistor book, usually then you're okay. So maybe you just need to increase the price to $500-600. Oh, seriously, how bad is that wire that it doesn't even want to solder? Alright, that's better. Let's scoot. Alright, that's everything. Of course, I more than likely have put one of the LEDs backwards. It's almost inevitability. Oh, we've got to solder on the power lines. We're going to take them from this one. This is the 16 LED version. It was a 2-channel setup, but it had no current balancing. Not that it was really a problem. And also that has the 4000 Kelvin LEDs compared to the 5000 on this one. That's a terrible connection. That is really bad. If I see someone doing a soldering joint on a production like that, and they can redo it. But since it's me prototyping and I'm aiming for the destruction of everything, we're going to ignore it. Some of the problem is the fact that the aluminium itself is drawing away the heat at such a rate that it can't even reflow properly. Right, let's see if we go for the blindness test coming up. Let's see, for the power supply, we can go 24 volts, we'll go 25, and then we set the current to 6. We're going to go 500 milliamps. 600 is theoretically where it should be at, but I want to see what 500 is like initially. Right. I'm going to need a safety squint here. There's going to be a fair amount of voltage drop across these wires too. Alright, here we go for destruction. I'm putting my hand over this. Well, that looks like they're all running, so Anel lost his bet. Yeah, that's all of them. I see pretty colours. Wow, that's blinding. But is it actually enough? That's the trick. Ah man, I got rings in my eyes. Gonna turn that off. So you can see the massive difference in sizes there. Okay. And I use an O-ring to hold it up. It just slips over the barlow. Yeah. Alright. Probably going to get a lot of shadow casting, I'm guessing. But hey, prototypes, they're there to suck away your hopes and dreams. Okay, let's go back to the microscope view. Okay, so I've got nothing. Interesting, that's got a pink tone on it. I suppose I better get a circuit board, eh? I would say straight off the bat, no, it's still nowhere good enough. Not sure. It's part of the problem is that it's got a lot of broadness in the light. And I think because the LEDs are directly overhead, there's a lot of direct reflection back. Yeah, I'd say the directly overhead LED is a bit of a problem. Let's see if I can adjust the colouring of the camera here, because that's very much off onto the other spectrum. Let's see, because I've got all sorts of adjustments made for the camera. Okay, automatic white balance. Okay, there's white balance. That's fixed up. Okay, now that the white balance is fixed up, looking at the screen, it actually does look pretty good. There's a better overall color. I'm just gonna, whoops. We're just dropping the HDR at the moment. So we were on level 4 HDR. It's way bright. So that was what our original, I feel like around about that. So that's 2. Yeah, that feels better in terms of visuals. Certainly, let's see how hot this thing getting. The heat's not too bad. I can actually rest my finger against the aluminium plate and it doesn't burn me. But yeah, we might have to add a diffusion layer. Because there's definitely a lot of direct reflection coming back at me there. But how does it look for you guys? How does it seem relative to the old light? Need a 60-foot. No, actually I think we've got enough light now. It's a case of making the light better. And we're not actually at full current, so I've still got another 100 milliamps to add, but I suspect so it's 12 watts going in there. That's quite a bit. I suspect if I push it up to 600, we're not really going to see much of an improvement. But I'll do it, but anyway. So that's 600. Yeah, we're not seeing it. And drop to 400. Okay, we really start to notice. That's 300. Oops, shit. Sorry. So 600 is the maximum. 500. 400. 300. That's pretty good. Like 300, I'm actually able to still use that. I think the camera might be compensating a bit with. So back to 500. What do you think of the angular microscope lights that mount at the back of the microscope? I haven't really tried any of those sort of things. Well, let's try and solder something. Definitely the reflections are absolutely. I could put the. Let me try and put the. What do you call it? Polarizer on. Normally I leave the polarizer off because it is very demanding with the amount of light it eats. Let's see, where's all my optics? Hello there, Cyrillic F-Tip. Andrew, I think it is. Okay, so this is the polarizer going on. The nice thing is the polarizer actually helps me too. Definitely still plenty of glare there, but it kind of feels like it actually is a detriment, the polarizer. It feels more like I'm looking through excessively strong sunglasses, and it's not really helping. So yeah, I think a diffuser. Yeah, 600 is the maximum because it'll be 4 chains of 500, 4 chains of 150. Yeah, so I gotta get the polarizer off. Wow, why are you stuck, polarizer? Off is definitely nicer. Alright, so the whole point of this exercise anyway is so that I can do hot air rework with a more upright angle. So let's try some. So previously I would be limited to about this sort of angle. But now I can actually come in at a much steeper angle like this. There, so before I'd be looking at about a roughly 45 degree type approach. But now I can come in, it feels more like about a 60-65 degrees. It really lets me get above the chips, which is nice. That's the intent of this. So I think if I put a diffusion layer or something over the top of this, it should be good. The reason why I want more upright as well is that it lets you get a better distribution of heat over the part. Yeah, so that's good. And likewise with the tweezers, if you're say working, you can really get in, you can see how upright those tweezers are, whereas before that's about as far as I could go. But this upright. So I guess the question is now, what do I do about the diffusion layer? Overall, I'm definitely happier with the coloration, but yeah, it just needs that little bit of diffusion to help us out. Like I can see the blues showing up properly now for the UV rework. That actually shows up as a nice blue, whereas it never used to. It was more like a muted dark navy. So yeah, colours are much nicer. In terms of thermals, that's really not, I can hold that. So that's probably about 45 Celsius. So I'd say when it's running around 50 Celsius, which means the aluminium board is doing its job. I don't need to add any more heat sinking. That's working as planned, which is nice. So yeah, we just got to add a diffusion layer and that we should be good. Maybe I can find some sort of very thin material and just stick it over the top. One way, yeah. Well, Lewis is off doing a very different sort of style of thing now. And for some people that's interesting. They like to watch Lewis and what he's up to and what he's doing with the right to repair and Futo now. And for other people who want more just board repairs and electronic stuff, then there are other people such as myself, or you got Tim Herman, and then there's the Coder. Yeah, there's a bunch of other people out there which are doing the board repairs still. Lewis packed away his streaming computer, no more videos. Like I said, he's busy doing his other stuff, and yeah, it sounds like it's taken a bit of a toll on him at the moment as he goes through the transition process. I know it would be psychologically it'd be quite different to go from being one who directs your own business and you are the boss to having to work for someone else. I mean, we all do technically work for some, even if it is ourselves or maybe our partner, in the fact that you are trying to achieve certain goals, not just for your own happiness but success. And so for him to now have gone from all these years of being a self-worker to what he's doing now, it's going to actually be quite difficult. There's going to be some frustrations, absolutely. And he's that tendency. I think if you already have the inclination to be the sort of person that does your own business, it's very difficult to turn off that tendency to try and take control of the steering wheel and direct things how you want. And you also are somewhat less inclined to have to report on your activities so much. You sort of think, well, I'm going to try this. I've justified it in my mind. I'm going to go out and give it a whirl. But you can't do that all the time. And some bosses will let you do it. Like, I don't know what the corporate structure is like there. I know when I was working in South Africa, I was very lucky that my boss pretty much gave me free rein within reason. I didn't have free rein on the budget, but I did have free rein on what tasks I was approaching. So long as I handled whatever job requests came in, and anything outside of that, if I wanted to explore something else or whatever, if I was taking some time off, that was fine. It was a trust thing where they trust you to handle the tasks at hand. So I'm not sure how he's going with it. I hope he's doing well. I know it'll be a big transition. I know for me it was. When I finished up working in South Africa and I came back here, it was very nice to actually go back to working for myself again. It was good to experience being involved in a large corporate structure like that, but even though I don't make as much money this way, I am happier this way. Circle of milky PVC like a milk jar. Yeah, except PVC dries clear, doesn't it? But you might maybe even just high temperature silicon. That might work. Like, even though it's, I guess what we're worried about here is not absorbing too much of the light. So I don't know how different kinds of silicon will go in terms of absorption and retransmission. Even though they're transparent, they will filter out certain parts of the spectrum. Paul S, yes, I'm looking forward to Paul S doing his stream, because Paul S is a very good example, I think, of a appropriately pedantic and very well structured type of approach to repairs. He's excellent at his work, diagnostic and in the actual rework itself. I can't recommend him highly enough. I do remember it was fun when we were both on the chat side of Lewis Rossman's streams, and then Paul started working for Lewis Rossman, and it was one of the few times where the YouTube chat app applying for the job actually worked out very well for Lewis. The main thing is he's doing what he's passionate. Exactly. You got to be passionate about it. If you're not feeling like it's working for you, it will sap you very quickly, and you'll start getting cranky at so many things. I do hope it works out, and I hope that he doesn't get too encumbered by the political structure of it all. Because when he was doing it for himself, he was free to duck and weave and change as he wanted. But anyway, we'll see how it works out for him. Well, Anel, you see, there you go. Like I said, I reiterate my point. Paul S was one of the few ones that worked out. Alright, so overall I'm very happy now with this ring light. It produces enough light, definitely. In fact, it actually produces more than enough light. I might even create another one or two and use them as studio lights, little portable studio lights, although I do have a 120 watt spot lamp coming out soon, so I'm just waiting for Amazon to deliver it. We could put a DC jack on that. I might try that, see if I can find one. The other thing we've got to do is actually, I can't use that, well actually I could, I've got a spare power supply, but I generally can't use that power supply constantly. But I do have one of these things. You can get a PCB version of it, and this is the regulator for the LEDs. It will do up to 700 milliamps, and so I would just simply put that there and then plus and minus, and this here is the adjustment for how bright you want it. For now, I'm just going to try it with the power supply for a bit. Like, I might hook up the second power supply since I'm not doing anything with it. It's a bit of an overkill, but you got to do these things. So angular light frees a lot of surface around the lens. What's this? White. What? Photograph a trick with flash is to put white paper in front of the mask if too bright. Yeah, that's true. Maybe even I could just use something like rice paper. Just something that is quite thin but still has a decent level of transmissivity. I am worried that if I put paper on there, it's probably going to almost immediately reduce the output by half. Let's just try a piece of paper here as a diffusion output. It's looking like I'm looking into the eclipse. There's a bit of a dud spot there, but that is not actually a bad light. It's just simply a gap in the board. Ah, man, that's still bright. Yeah, this one here is a buck converter. You can also get boost converter versions, so you can just drive them from 5 volts or 12 volts. But I decided to go for the buck converter version. I didn't bother with the SEPIC or the buck boost type ones because they add more complexity and they generally are less efficient, whereas the buck converter ones tend to be pretty good on the efficiency side of things. 120mm downlight will have the right size plastic. Yeah, that's actually not a bad idea, Tradie Trev. Yeah, I see people throwing them out a fair bit. So that might work, and then I can just, so I mean, what do you downlight? You got 72mm downlight size, I think, something. But yeah, a downlight diffuser would probably work well. And if it's poly whatever, no, I should be able to cut a hole out that suits. What about the diffusion layer and an LCD? You could use that, yeah. Let's see. Alexi, your capture board buttons work fine. Oh, that's good. Finally, someone actually have one that works. Baking paper is another one I was thinking of, Therese. Yes. Yeah. There's a few options, and then of course you've got to work out how far to offset it. Hot glue won't work in this case. I will have to use little dots of silicon to bond it down. Hot glue will just melt. I mean, I know I'm saying it's only 45, 50 Celsius, but that is just starting to get to the point where some hot glue will start to sort of like, particularly on the surface, it will become a little bit viscous, and it will sort of slide off. So a couple of dots of silicon should do the trick nicely. Polarized lens tool and rotate to control the intensity. That's a bit more of a complex. The downside, of course, of the polarizer is your 50% hit straight up almost. Anyway, I just found another one of those boards that are dud, so we're going to replace that. I'm surprised. I did not think this was going to turn out as well as it did. It needs some improvements, perhaps, but I'm actually surprised. The light is good. The 5000s, they're nice. And now that I've adjusted the microscope camera to suit, it works out pretty good. It looked pretty gnarly before I adjusted that HDR setting, but in retrospect, it actually shows how bad I think the original ring light is. Okay, let's see, connectors, what have I got? Round, square connectors? I'm not sure. Try round connectors. Oh, right down the bottom, mate. Right down the bottom. Jeez. The semi-one, that's the 3D printer fuser. What sort of material would you use for the diffuser? It'd be interesting to see if you had a spectral analyzer and see what goes in versus what comes out. Great USB. I could have sworn I had some DC jacks in here. What the hell are you? Oh, wow. Wow, this is one of my very old homemade things from my model aircraft stuff. I'm gonna have curious to have a look at that. Pet G. Yogesh, no, they are 5,000 Kelvin. 6 is too much for me. It hurts me. But 5,000 is nice. And they are supposedly 97%. Ah, there we go, we actually do. We've got one left. Yeah, supposedly they're 97% CRI, which is nice. Anything less than 95, and at least in terms of manufacturer rating, tends to be a bit dodgy. The only thing is, do I really want to put a DC jack on this? Because then I don't really have a way to... Yeah, if I put a DC jack on this, I don't have a way to actually plug that in yet. Because I haven't got a cable set up for it. So that might be a pass for today. But yeah, I'll be very what? Me no speak proper English? Jeez, Paul. I'll be very happy to see the end of this particular assembly. I'm just trying to find my LED. Where are you? Oh, sorry folks. Right. Oh, bravo, I've bloody well cable tied everything together like a moron. Cable ties, what are they good for? Absolutely nothing. Okay. Right. Okay, so this is the old controller. So it was 12 volts, 4 watts. And it's 144. Like I said, there's nothing technically really wrong with this 144 LED unit. It served me very well over the years. But I had started to notice on the camera that, you know, the coloration just wasn't there in the microscope view. Might just get another one of those O-rings. Hey Daniel, welcome. Okay, so I'm just sliding a ring up on the Barlow at the moment. By the way, if you don't have a Barlow, then it's going to be difficult to mount these this particular LED assembly, because I need the Barlow. It fits over the Barlow. If you've got a non-Barlow setup, then it's you have to find another way to mount it. You can just use, usually with the microscopes they supply you with a blank ring. So let's see if I can find it. They supply you with this contraption. Actually, let's see if that... Yeah, that's okay. That's interesting. I could It's not quite enough there in terms of thread, but what I could have done is use this, and then that screws into the actual primary objective area. Let's see if it even fits. I'll give it a shot. I can test it without taking my bilo off. Oh wait, no, I'm an idiot, I'm backwards. Everybody's probably saying, yep, we knew that, Paul. We knew that. Or am I? No, I'm right. I'm right. You're all the idiots. Yeah, that's not gonna work. That's a bit sloppy. Too sloppy for me. I'm gonna stick with my O-ring setup. Alright. These are just random bits of optics that I've got for them. Like that's a 0.5 Barlow, and I've got a 1 around here somewhere. Yeah, this is it. When they say a 1 by or 1 multiplication Barlow, it's just simply a straight through piece of glass. There's no magnification whatsoever. But I would always recommend it. You should always have some sort of filter, glass or something in front of your primary objectives on the microscope, because you can easily clean and replace these. You cannot do so with your Barlows, with the primary objectives. These are pieces of crap. I don't know why I still have it. I think it's just, yeah, the biggest piece of crap ever for attaching a microscope. Okay. So we're going to have to deal with a little bit of glare for the moment. But I'll do some experimenting and see what I can come up with for the diffusion layer. Like I said, I don't want to lose too much light. Obviously I'm going to have to lose some, but let's try and be thrifty about it. That didn't work. Hey there, Ben Wilson. Yeah, I tried the 0.5 because at the time that I bought the microscope, everybody was, well, I shouldn't say everybody, but people were either using nothing, like Lewis, or they were using a 0.5 Barlow, say like, I think Jessa was using 0.5. But I wasn't happy with either option, and so I postulated that there should be a 0.6 or 0.7 around. Unfortunately, I found a 0.7 and way down. So yeah, how does everybody feel about the color rendering on this now? It does feel nicer from my perspective when I look at the screen, but then again, I could just have a super saturated screen at the moment. I need to update my computer screens. They're not really that great anymore, especially now that I've got the Dell Ultra Sharps upstairs, which still pale in comparison to the glory of the iMac screens. I'm sorry, I know people don't like to hear positive things about Apple products, but those iMac screens are a wonder. They're pretty much the only gloss screens that I would ever own. Of course, the whole PC monitor market may be heading for a colossal shake-up soon, with OLED becoming a de facto thing in the near future. So certainly when we get OLED, I think that will be the big transition again. I know we have it for normal screens, but I'm talking about everyday. Okay, yeah, we definitely need some diffusion there, but it's good. It's good overall. As long as you don't hit the directly perpendicular surfaces visually, it's really good. people wondering what's going on here, I'm just replacing these switches because for some reason this particular brand or model of switch really did not like me doing a full fill on the legs. Something happened internally on the switch and ruined them. It was marginal because some of the boards I sent out seemed to be okay, like Alexi's, and I know my prototype one was okay, but there are definitely others out there that didn't survive. Now, I am causing a bit of damage to the circuit board, definitely a bit of damage. Fortunately, it's redundant, these connections, so yeah. Oh, that's right, I'm using up my goot wick for these. This is actually one of the goot wicks that work really well for this sort of stuff. There's a few others that people pick up and it's not as good in the weave. Let's see if I can find the other one. There's some goot wicks and the weave is just too coarse, which is why I ended up, after Chris Long suggested, I ended up with the tech spray as my primary wick for all this sort of work. Oh, Daniel, that would have been difficult to get it out. How'd you end up cleaning yours? Just persistence and frustration? Because yeah, it can be very, very difficult to get things like flux fumes out of the lenses. So good job getting it clean though. I know some people have done things like put their optical elements into the ultrasonic cleaner. It's probably not a good idea for a lot of us. Mostly because in the ultrasonic cleaner, if you've been using it for, anything electronic related, there's still going to be a lot of contaminants in there that will stick to the glass. So if you are going to do ultrasonic cleaning of your optical elements, you really need to do it in a very clean ultrasonic cleaner. Hey, Ismaila. How's things over in Malaysia today? Been a long time since I've been to Malaysia. I think the last time I was there would have been late '96. That was at Kuala Lumpur. I was young and dumb, having fun. So patience, persistence, frustration. No, I'm not surprised. Well, definitely deserve a pat on the back for yourself there for pushing through and getting those elements cleaned. It's definitely not easy to do. There's almost always, there's something you spot after you think you've got it clean. There is so much solder in these pits, in these holes, which was intentional. It's like that was the whole point, is I wanted to absolutely fill up all those holes to make sure that they were holding the switch properly so we wouldn't have any sort of fatigue issues, but it ended up biting me in the backside, it seems. I was lucky with getting the microscope in that because my father was into photography quite a bit, as a kid, he handed down all the various little useful tidbits of information, like always have a sacrificial element at the front and things like that. Small things like that get passed down just as general knowledge. And then later on you realise, I'm going to avoid this potential disaster by fixing it before it happens. Unlike me with these switches. Why not a plunger? Mostly because the plungers, the scale we're dealing with here and the awkwardness of the board, they just tend to make the board kick around, and I do even more damage to the pads. I did use a plunger in the previous one I tried, and I think I tried it about 3 or 4 times before I gave up. It was like, no, I'm just destroying the board. Okay, that end one's not sitting properly. What's holding you up? Well, what's holding you up is a bent leg. You're going to try and fold back down. There we go. Like I said, I have encountered this issue before where when you reflow or when you solder in the switches, sometimes they can have this problem. But the last time was a good 10-12 years ago with little tactile switches. So I was kind of shocked when it happened again. So I don't know whether it's a manufacturing weakness or just me being excessively judicious. Anyway, so for this particular task, I'm just going fairly minimal and very quick. So mechanically, it's not as good as I would like, but I'd rather have that and the switches work than have an extremely robust installation and the switches don't work. Did Tim send me some paste? He has sent me some thermal paste, yes, and I have been testing it out on the side a bit. Yeah, obviously I need to, this is nothing against Tim or anything like that, I need to run my own tests as well. And then, I can report my findings. If you're wondering what these sections are here for, they are just for if anyone, because it is a, tiny 45 with a USB connection, they're just there if anyone wants to fiddle around and repurpose things. These are just external header options for the same switches, just different things people can try if they want. That's a dead bug. That there's obviously the programming header. I don't think anyone really will do anything with it, but I figured, why not? The space was there. And the different pitch, obviously. I think this is a 1 mil pitch and this is a point. Yeah, I don't know. Oh wow, how did I miss those? I think it's good that Tim has moved into that kind of area, found something outside of just board repair. I think we all have to do that if we want to survive. I mean, board repair for MacBooks as a business, it's been good, but we're certainly getting a situation where there's a lot of competitors around. So you do want to have something unique for yourself, and I think Tim doing the thermal paste is a good idea, particularly the fact that, you know, he's seen the problem we had with the newer ones that have that chunky paste, and he's, you know, come up with a solution. So it's great. Yeah, I'm definitely very happy with that. Very happy with that light. Like I said, once the diffusion issue is sorted out, I think it'll be good. Okay, so let's see if this works. I have to disconnect my current meter. Well, the LED works, so it must be working, so we'll ship that. Let's see, schematics. Okay, let's go corner. Alright, so that's tab, that's working, return is working, shift tab's working. Shift tab shows up as tab still, but in Flexboard view it gets interpreted appropriately. So yeah, so yep, that's working now. Fantastic. And I can mark that as okay. Another one on the list, on the pile. Alright then, well, that's probably it for me today. I've you know, achieved what I needed to, and I'll mess around with the diffusion layer tonight, see what I can come up with. You know, hopefully we can just find something that's simple, but doesn't take too much of the light out of it, because yeah, it's, you really want to try and preserve as much of that light as you can, and that is half the challenge with creating diffused light, is that it's very easy to create diffused light if you've got an unlimited supply of light. It's a little trickier when you're trying not to lose too much. When, you know, it heats up everything as well if you're absorbing too much and not emitting enough. So, alright, I'm out of here. Thanks for watching. Appreciate being around, and it looks like we'll consider this a success. So, once again, third prototype ends up being the first one that really does work, and then from there you can go into the refinement stage. So, I'm out of here. You take care. I'll see you next time.